All right, we have found ourselves in section 3.3, which is where we're really going to get into some different rules for finding derivatives. So please make sure your cell phone is put away and I have your complete attention for the next 10 minutes or so. So far, previously, we've been using that limit definition to find the derivative of a function. So for example, if I said find the derivative of the function x squared, up until now we've said the limit as h approaches 0, remember, of f of x plus h minus f of x all over h, so this is f prime by definition. So that became the limit as h approaches 0 of x plus h squared minus x squared all over h. And then that became the limit as h approaches 0 of x squared plus 2xh, if I distribute that power, plus h squared minus x squared all over h. And then the x squareds zero out, and the terms that remain all contain an h, as we would expect. So then I have h times 2x plus h all over h. Those h's divide out, so now I'm down to just the limit as h approaches 0 of this expression, which of course is 2x. So the derivative of that original function would just be 2x. So this technique is a little bit tedious and a bit limiting because we can only do certain functions using this technique without knowing some higher level either algebra skills or trigonometric simplifying identities, things like that. They can get pretty intense and pretty complicated. So what we're going to do now is we're going to learn some shortcuts. If you've ever taken calculus before, you would have learned these shortcuts. If you have not, that's okay too. It's not going to be a problem. But these shortcuts will make your life a lot easier. And from here on out, unless the question specifically says to use the limit definition to find a derivative, I want you to go ahead and start using these shortcuts. So a couple of basic rules I want you to be familiar with. First of all, d dx, remember that notation means the derivative with respect to x. So the derivative of c, where c is a constant, maybe make that note, c is a constant, would just be 0. That's the first rule. And that should make sense because if it's a constant function like y equals 3, that would be a horizontal line. So the derivative would be the slope of that line, which would be 0, right? It's a constant function, slope is 0. No big deal. Now, the next rule is called the power rule, and this rule we will use throughout the rest of the entire course. This is probably the most important derivative rule we'll learn. And it says the derivative with respect to x of x to the n. So if you have x raised to some power, x to the third, x to the fifth, x to the 1/2, the derivative can be found by bringing that exponent to the front, so n, and then taking 1 away from the exponent. So nx to the n minus 1. So for example, if I said, what is the derivative of x to the third? In that example, n would be 3, so my derivative would be 3x to the 3 minus 1, so 3x to the second would be my derivative using the power rule. The next rule is called the constant multiple rule, and it says if you are multiplying a function by some constant c, then you can basically bring that to the front if you want to think of it that way, but it's really just the derivative will be c, that constant, times the derivative of du dx. So for example, if I said, what is the derivative of 5x to the third? Then it would be 5 times the derivative of x to the third, which we just did over here. So it would be 5 times 3x squared. And then we could simplify that to say 15x squared. So basically that constant, you just save it till the end and multiply it back through. Lastly, we have these sum and difference rules that say if you are adding or subtracting multiple terms and taking the derivative, you just take them term by term. You just go down the line. So the derivative of u plus v would be du dx plus dv dx. Same thing if you're subtracting. And then finally, if we're looking at a sine or a cosine function, the derivative of sine is cosine. That's it. It's just a rule to remember. Derivative d dx of sine is going to become cosine. the derivative of cosine is going to be negative sine. So these you'll want to get memorized. All right, let's do a couple of quick examples and then we'll do some practice with these in class. So the first one, we have f of x equals x to the fifth. So be sure to get in the habit now of using good notation. This is f of x, so I don't want to see anything like this. I don't want to see equals and then you write the derivative. That's not what I want to see. I want to see f prime of x, derivative notation, equals, and then take your derivative. You've got to make that distinction between the original function and the derivative. That's important. So this is a power rule where the n is 5. So using the power rule we just talked about up here, this is going to be 5x to the 5 minus 1, so 5x to the fourth, and that's your derivative. The next one, we've got the cube root of x, and notice that a radical we don't necessarily have a specific rule for. However, remember we've talked about this previously in the course, if I have a radical, I can rewrite that using an exponent. Remember the little rule for radicals says the nth root of x to the m can be written as x to the m over n. You need to recognize that and remember that rule. So there's an implied 1 here, so this can be written as x to the 1/3. Now it's in the format I need to apply this power rule. So my derivative then is going to be 1/3 x to the, and then we got to take 1 away. So I'm going to get a common denominator of 3, so that's 3 over 3, so that becomes negative 2/3, and that's going to be our derivative. Remember, when you have a negative exponent, to make it positive, you move the term back to the denominator. So if you want to write that in the denominator, you would write it as 1 over 3x to the 2/3 power. However, that last step is not necessary. The negative exponent would be fine. Okay, letter C, we've got 1 over x squared to start off. If it's in the denominator, again, I have to have it as x to a power, a number, to use that power rule. So using that same rule I just talked about here, I'm going to rewrite 1 over x squared as x to the negative second, and then just rewrite the rest of it. Now write your derivative notation. So y prime becomes, use the power rule here, this is going to be negative 2x to the, remember you subtract 1, so it's negative 3. Negative 3x, that's an exponent of 1. So using the power rule, that would be negative 3, let's see, it's the constant multiple times 1x to the 0 power. Anything to the 0 power is 1. So that would just be negative 3 times 1, or just negative 3. And that should seem reasonable because 3x is a linear function with a slope of 3, right? So the derivative would just be 3. So when you have 3x, 2x, 6x, whatever, that the derivative is going to be whatever that coefficient is. And then lastly, 5 by itself is a constant. So remember the derivative of a constant we said is just 0. I'm going to write that just to be emphatic. Of course, you don't have to write that. If you want to clean this up just a little bit, you can write it as negative 2 over x to the third minus 3, and that would be our derivative function. Lastly, we've got y equals, we've got this radical again, so I'm going to rewrite that first. So this is rewritten as 6 times x to the 3/4 power minus 2 cosine x plus 5 sine, oh, let me rewrite that so it's a little bit cleaner here. I did not leave myself enough room. Let's try that again. Let me come down and write that again. So this is y equals 6x to the 3/4 power, using this rule right here, minus 2 cosine x plus 5 sine x. Okay, so then the derivative would be 6 times, that's that constant multiple rule, 6 times the derivative of x to the 3/4. So that's 3/4 x to the, if you subtract 1, common denominator, 4 over 4, that makes it negative 1/4. Minus 2 times the derivative cosine. Well, that's this function right here. So that's negative sine x plus 5 times the derivative of sine, which is right here, and that would be cosine x. And if we want to clean that up slightly, 6 times 3/4, you can reduce it or not. I don't care. That's 18 over 4. I'm going to leave that exponent negative just for now. Negative 2, negative sine makes that plus 2 sine x, and then plus 5 cosine x at the end. And that's going to be the derivative. So we're going to do practice with these. You want to get really, really, really proficient at these rules because we're going to use them all throughout the rest of the semester to do other skills. So be sure to be in class and we will practice them tomorrow.